Bonjour, mes amis. It is wonderful to have you here this evening, an evening where we are going to be exploring and discussing some biohacking. When people undertake biohacking, there may be many different motivations. Some do it to the end of, I have family and I want to be there with them in a very healthy way. Others do it because they just enjoy, gaming the system and seeing how far they can take it. Regardless that motivation, biohacking does boil down to this idea of how can we best show up and serve our body so that our body gives us the health that we can make our years the best they can be. And arguably how many years that we do have, how we can extend that, right? We all enjoy this delight that we have on this planet. And so tonight we're going to be talking with Dr. Kara Fitzgerald, who has done some incredible research in this space. Dr. Fitzgerald is on the faculty at the Institute for Functional Medicine, and she is an IFM certified practitioner and lectures globally on functional medicine, longevity, and epigenetics to practitioners and consumers alike. She maintains an award-nominated podcast series, one I encourage you to check out, called New Frontiers in Functional Medicine, and is the author of the most delightful book, Younger You. Dr. Fitzgerald is also engaged in clinical research in epigenetics and longevity, the very principles behind biohacking, and uses diet and lifestyle interventions, and has through that developed studies that look at how you can reverse your bioage, how you can leverage tactics and techniques to realize better health through DNA methylation supportive diets and lifestyles. She was published in April 2021 in the journal Aging, and this was specific to men. And then there was a subsequent publication that also looked at women and how diet and lifestyle can lend to better outcomes. Just this year, she's published an assessment of the most influential dietary changes for reducing epigenetic aging. Welcome to the stage, Dr. Fitzgerald. Bonjour, or hola.
Hi there.
Hi, how are you doing this evening? It's so wonderful to have you on to start this
Good.
conversation.
Yeah, thanks. It's nice to be here.
Yeah, we have a very engaged audience. So I'll warn you, audience, we will be taking questions at the end, but you'll probably see comments and questions popping in as we go along.
I love it. Yeah,
Yeah.
it's fabulous.
So why don't we start at some of your foundational research? Can you tell me a little bit about the research that you've done that looks at how diet and lifestyle can reverse aging, that biohacking?
Yeah. So we got into this a while ago, and I'll just extend you the option to to interrupt and clarify and whatever you need to do, because I can just go off, as you already discovered off camera. I can go
I
off
love
on
the
a
passion.
tangent.
Have fun.
I always like to say that we came into this really before we knew that biological age could be reversed in humans. In fact, it was thought that it couldn't. I got interested in epigenetics probably around 2013. And then by 2016, we had designed a diet and lifestyle intervention that we brought into clinic practice that we ultimately tested. But our original interest came because there was a lot of the bulk of the science at that time was looking at cancer epigenetics. And so cancer very efficiently hijacks gene expression for its own nefarious ends. It will turn genes off that protect us. So, the tumors, the so-called tumor suppressor genes, BRCA is one of the most famous ones. In the cancer microenvironment, it will turn that gene off. There's tons and tons of other tumor suppressor genes as well, and it will manipulate those. And then it will turn on oncogenes, genes that allow cancer to move forward. And those studies were coming across my desk, at a pretty active clip. And I finally, along with my nutrition director in the clinic practice, we finally really put our heads together and thought, can we do anything about this? Does functional medicine have a role to play in manipulating gene expression, manipulating epigenetics? We certainly talked about it, right? People who've been around since that time have certainly heard the term nutrigenomics, et cetera, et cetera. But I think really it was more, we were existing in the realm of hypotheses and not with actual data. There were no human data. In fact, ours was the first of its kind. It was the absolute first diet and lifestyle intervention to look at epigenetics and specifically bioage clocks. So we brought this into clinic practice and we saw that people responded. Some of those classic methylation markers that you're familiar with, homocysteine, et cetera, clinical outcomes, inflammation dropped, et cetera. So we saw that the dietary pattern worked clinically, but we couldn't at that time, epigenetic tests weren't available to us. By a fairly large miracle, we were given an unrestricted grant to investigate our intervention in a randomized control structure, and we were able to hire a clinical research center, which actually was the Health Gut Research Institute at my alma mater in Portland, Oregon, National University of Natural Medicine. And so that was 2018. And we were able to look at the whole methylome using, the epigenome, basically using a specialized test yet to be available to us. During that time running the study, it was the first publication showing that biological age could be reversed in humans came out. So we were in the middle of our study, and we knew we would look at the clocks, but then it became very exciting to us. So the first publication that we undertook was looking at the clock. So we had a 20-person study group. They did our dietary and lifestyle intervention, and then we had a 20-person control group that didn't do it. We measured epigenetics in both, among other things. We looked at cholesterol and folate and lipids and also, just a handful of other things. But we could see at the end that those who followed our dietary pattern were effectively, over 3 years younger epigenetically when you looked at their bioage clocks as compared to the group that didn't do the intervention. And the within group comparison, so the study group before and the study group after got just over 2 years younger. So from both comparisons.
Okay.
And this was an 8-week interval.
Which is so incredible for me to hear that over the course of 2 months. So I want to take us a step back, if you could, and explain to the audience what these methylation or aging clocks exactly are, because I want to make sure that the audience has a good concept of, you can track your age based on a calendar, how many times you put a happy little sun, or you could track age based on some of these clocks that you're talking about. Can you ground us a little bit?
The whole and the science of measuring biological age is just growing by leaps and bounds. Probably the cornerstone tool that is used, still today are the epigenetic clocks. And so epigenetics is above genetics, epigenome. And this is looking at the biochemical marks on the DNA that change gene expression. And there's predictable patterns that occur that are associated with the rate of aging. So biological age is how fast the body is aging physically, where chronological age, as you pointed out, is just, birthdays you've celebrated, trips around the sun. You can't do anything about it, but we do indeed have, much choice over the rate of aging. And so the epigenetic clocks look at the rate of biological aging through the epigenetic lens. There's other ways of doing it. You could do, people have probably, maybe they have on their wearables a VO2 max. You can look at the rate of lung aging, or there's skin tools to measure the rate of skin aging. And the sophistication of the clocks is, the epigenetic clocks is growing, but that's what we used in our original. We actually used the first sort of flagship clock called the Horvath clock. The Horvath multi-tissue clock is what we used, and that's still being used today. It's still a highly regarded clock.
Yeah. So you took a group of first middle-aged men and then middle-aged women, and you were able to say over the course of 8 weeks, 2 months, based on a program that you had created, diet and lifestyle intervention. So nothing fancy or sexy in terms of, you weren't sending them to these advanced, technological treatments. It was simply eat better, sleep more, spirit. And you were able to peel off biologic years during that period.
Yeah, that's right. We were, and our two groups were healthy. And that was important to us to not, if you have an illness, if you've got Really, even an acute illness can sort of temporarily accelerate age. But if you have one of the chronic diseases of aging, if you've got diabetes or if you've got
Mhm.
heart disease, dementia, anything like this is going to accelerate the rate of aging. And we wanted to isolate the aging phenomena versus the disease's influence on aging.
Yeah.
And so both cohorts were healthy.
Yeah. Okay.
And so, yes, we, within this healthy group, we were
Yeah.
able to make them biologically younger as, measured by the class.
Which is such interesting and powerful reason. Like I think of, when we had that turn in psychology, that for the longest time, psychology was just studying that was unwell, right? We had the same idea in medicine. For the longest time in medicine, we only studied those that were sick. And so it's interesting to me that you're contributing to this idea that medicine is for all people, including the healthy,
Yeah, for sure.
which is
That's
which is
right.
novel. Yeah, can you explore for
Well,
myself?
and I mean, you can take so I should say that the expectation is, and the science demonstrates that if you bring this intervention or other if you
Mhm.
it to, to individuals who have an illness, like if we had looked at a cohort with diabetics, we
Mhm.
should see a larger bioage reversal because
Mhm.
they're aging at an accelerated rate. And on average, one study put those with diabetes about 6 years ahead of their chronological
Yeah.
age. You can
Yeah.
look at it like the disease process is very much an age accelerant. So if we had we would expect to see more biological age years shaved
Yeah.
off.
Yeah, I've seen that in my clinical practice. I haven't done that larger group study, but in N of one, so audience being just one person, my patient,
Yeah,
the more that is wrong with them, I'm using air quotes there, if they are committed to it, the more the change in that clock we will see,
for
right?
sure.
Yeah,
Yeah.
so can you explore for me and for the audience, what are some of those things that were incorporated into those 8 weeks? Like what did
Yeah.
those 8 weeks look like for the people?
hmm so we did, it was our best read on the literature. And if you remind me, Kirsta, we can swing back and I'll talk a little bit about some changes that we'll make going forward. Um, so everything that we did was based on some evidence in the literature that it would influence favorably gene expression.
Hmm.
At the time, we had to lean on cell studies, we had to lean on animal studies. There were limited human data.
Hmm.
Now there's a ton more, which is very exciting.
Hmm.
Um, so our dietary pattern, and I'm sure you've talked about it here, was incredibly dense in two groups of nutrients. The first group, I'm sure your audience is familiar with methyl donor foods. So this would be beets, it would be eggs, it would be, leafy greens, mushrooms that contain folate and choline, animal products. We wanted people to do liver. Now we use it in caps. People weren't super thrilled.
That
It
was
was one of our least adhered to.
an uphill battle.
Yeah, for sure. It is, but it's easy in caps. Like I can take it in caps. So it was, just a collection of methyl donor dense foods and without a supplement, without a B vitamin to be seen, we increased circulating methylfolate significantly in our
Oh,
study
cool.
group. Yeah. So we had the evidence that they were adhering to this dietary pattern
Okay.
because we
Okay.
successfully did that. I mean, we successfully did a lot of things, but that was one kind of cool piece of evidence. So that's methyl donors because, the methylation cycle makes those methyl groups that then dot that are cornerstone to the epigenome. They comprise the methyl groups that make up DNA methylation. And again, our data showed that we rearranged DNA methylation. We plucked it and moved it and made
Mhm.
it into something more favorable on our intervention group. So we needed lots of methyl donors. And we know as we age, we actually methylate less efficiently.
Mm.
So always we need to supply a robust amount, and diet I think is the best way to do it. I'm not against vitamins, but we want to have a good core foundational dietary pattern. So methyl groups provide the methyl donors, but then it's like, where are they going to go? We want, this is how it's a red lollipop in the scientific literature is how they show a methyl group dotting
Yeah.
dotting the genome. So I
I
tend
talk
to
about
just do
sticky notes,
this.
but I like that.
Yeah, these little red lollipops.
Mhm.
So we're making those with the dietary polyphenol, with the methyl donors. But then we need to figure out where those guys are going to go. We
Yeah.
want them to shut down genes that are driving disease and inflammation forward. And we want to actually remove these red lollipops where genes that we want on are inhibited. So we really want this cleaning and this rebuilding of the epigenome as much as possible. So methyl donor foods, and then a class of foods we called methylation adaptogens. We're now calling them epinutrients, superstars, or superfoods. Mostly these are polyphenols. So the reason that you're eating your green tea or you're using some rosemary or turmeric or any of the spices, curcumin, quercetin, luteolin, like the reason, pomegranates are good, like all of these beautiful fruits, veg, spices, etc., that we consume are dense in these plant phytochemicals called polyphenols. They can help rearrange how DNA methylation is happening to something healthier. Our dietary pattern, we added it up. We wanted to find out how much polyphenols were present in our dietary pattern. We just published that as a letter to the editor this year. There's about 3,000 milligrams if people were adhering to our program per day, which basically dwarfs any other published polyphenol dense study out there. So it was very, very dense in this information. And we could see that it worked. We supported methylation and we moved it around in our study group. So that's the dietary pattern. It was lowering carbs, good fat, good hydration, sufficient protein, all of the other earmarks of a healthy diet, pulled out processed foods.
Sure.
And then we wanted people to exercise. So if you exercise is like a polyphenol in movement. Exercise acts like a vegetable. When you look at gene expression, the epigenome, and you look at it through the lens of exercise, it does a lot of the same stuff a healthy dietary pattern does. It's pretty darn extraordinary. So people needed to be moving. Stress is an age accelerant. Stress pushes forward the rate of biological aging. And so we wanted people to engage in some kind of a de-stress activity. And we specifically chose something called the relaxation response, which is just a very simple but evidence-based breathing exercise that came out of Harvard, many years ago. So we wanted them to sleep. We couldn't sort of make them sleep, but we gave them sleep hygiene tips. We kind of brainstormed and making sure they had enough runway to get adequate sleep. So sleeping is anti-aging, insomnia is pro-aging, movement is anti-aging. If we're very sedentary, that's pro-aging. Stress and de-stressing, both either pro-aging or anti-aging. And so we had all those pieces plus the dietary pattern. And we had people take a greens powder to just get a little extra hit of those all important nutrients and a probiotic.
Okay. And so with those, I don't want to dismiss them as simple because I would imagine for some people that feels like a big diet shift, a big lifestyle shift, but with relatively simple things, right? You're not trying cryotherapy. We're not talking peptides. We're not talking kind of the fringe
Safe.
of,
Yeah, that's
right? We're talking about very basic, accessible things to a certain extent.
Yes.
And you're able to, within the course of 8 weeks, that's the part that is magical to my brain. That quick shift that the body can quickly adapt and be resilient to.
Yeah, it is. And in a healthy cohort, I mean, that to me is pretty cool too, because it should, if we understand epigenetics, be harder to do that change. So what it suggests, so it's simple to your point. But food, lifestyle, it's ridiculously powerful. I mean, we were talking off camera about just kind of how powerful we're getting more and more sophisticated with our technology, with our ability to understand food and the sort of the sub nutrients in food, those polyphenols and the postbiotic compounds from food. just how extraordinary they are. I mean, they're just no joke at how
Yeah.
powerful they are. And um, I, I think we will lean into the power of diet and lifestyle more and more and more as we move forward, and we're able to look at them, in this through this sophisticated lens.
Yeah. Yeah. Or when we see studies like yours that very elegantly demonstrate in
Yeah,
short amount of time,
we could
small
do big
shifts.
stuff.
Yeah.
Yeah, big
Yeah.
stuff.
Yeah.
And that's not to discount some of the cool
Yeah.
next generation stuff coming out. I mean, I'm a fan of therapeutic plasma exchange. I think that there's
Yeah.
definitely a place for rapamycin for
Yeah.
some of us. Um,
Hmm.
I know Yamanaka factors, we were talking about those. I know
Yeah.
they're going to be coming to, safety trials in humans are about to be started. Big things are happening in the longevity science space. And what we're doing with diet and lifestyle
Yeah.
is absolutely important.
Yeah, I wonder actually you brought up the Yamanaka factors, and so I wonder if you can very gently introduce the audience to what that is, as well as I've never heard this phrase before, and it delighted me. So the idea of Yamanaka mimetics, right? So I
Yeah,
wonder if you can gently
sure.
walk the audience through what exactly that technology and that hope and that promise is, and then how they can access that right now at home through the mimetics.
That's cool.
Yeah.
We definitely have some research we have to do, but I'm
Yeah.
bullish on it. I'm pretty excited about it. So Yamanaka factors are um, these proteins. They're transcription factors, meaning um, they can change gene expression. So they can dictate, they can change, what genes are, manipulate what genes are on and what genes are off,
Mhm.
what proteins are being produced. They were discovered by Yamanaka. He was given the Nobel, along with another scientist. They were first shown to be able to take a somatic cell, so an established cell type, a skin cell, a heart cell, liver cell, etc., a neuron. And when exposed to these Yamanaka factors, these four transcription factors, that cell would be reverted to a pluripotent stem cell. So it
Mhm.
would take this defined cell and completely de-define it to, something that would be at the earliest embryogenesis, basically.
Mhm. Yeah.
It's
So
extraordinary. Yeah, go
so
ahead.
the idea is, and it's being mindful that, like when we, for the DNA 360, when we take our testing, we take cheek swabs, and we know that even though they have differentiated to be a cheek cell, we know that from that your entire genome is there, and we can take
Yeah,
that. It's just that these factors, if I'm hearing you, these are kind of factors that will untie knots and take that from being a cheek cell back to the original I can be anything cell.
yeah,
And the
that's exactly
promise,
right.
yeah, and the
That's right.
promise and beauty there is that, for example, if you have kidneys that aren't doing that well, the hope would be we could untie that cell and then it could become a kidney cell and support what isn't working well in the kidneys. I'm making something up,
Well,
audience,
I mean,
but
that's certainly one of the ways that Yamanaka factors could be used. Like, you could create new organs. That's definitely,
yeah,
an
yeah.
area of investigation if you
Mhm.
actually, to just transform,
Yeah.
transplant, the need for transplants, just completely change that. So these Yamanaka factors, transcription factors, it can take a somatic cell, revert it back to its pluripotent stem cell status. Um, but you can also stop it, so it's not going all the way back
Mm,
in time to, stem cell status. You can, let's say, take a skin cell, and you take a skin cell of a 50-something-year-old, shave off 20 years or 30 years, and then you've got a
yeah.
really young skin cell. This has been shown time and again. In fact, David Sinclair is one of the scientists who will be bringing these into human safety uh, trials really, really soon. And in his lab, they did a cool thing where they used Yamanaka in an animal model of age-related optic neuropathy. So these mice were blind due to an
Mm,
age-related optic neuropathy. and they applied the Yamanaka factors to the optic neurons, reversed the optic neurons' age. They were able to demonstrate that, not to stem cell status, they just made them younger, controlling the time exposure, and restored vision. So they did that in an animal model. Yeah, they did like a whole animal age regeneration and had some really interesting results there. It's not like a one size fits all cocktail. You can't like run to your nearest scientific supply house and grab a bottle of Yamanaka factors and suck them down and hope that you'll be 20 again, because it won't happen. It would be really dangerous to do that. But when applied correctly and controlled, some really, really interesting stuff is happening. And a friend of mine, Dr. Vittorio Sebastiano, who I've talked to on my podcast, he actually did a really interesting masterclass, and he was there as well. The masterclass was focused on longevity, so a lot of interesting longevity scientists. He's looking at ovarian rejuvenation, and the way that the lens that he looks through using Yamanaka factors, which is just badass. It's so interesting to me is, thinking about if you rejuvenate an organ, so you're just controlling the exposure in time, you're not taking it back too far. That organ, if you choose correctly, that organ can have a system-wide leverage effect. So let's think about keeping ovaries a little bit younger for longer. You're going to have better brain, better bones, better skin, better, well, obviously better hormone status globally, better muscle mass, etc. Yes, your reproductive years would also be extended as well if that's something that was wanted by that woman. But what the ovaries do is very system-wide, very system-wide. And we actually can see, the menopausal transition as being a pro-aging kind of a phenomena. So I think his work is extraordinary. He's also doing some work in skin regeneration as well and applying Yamanaka in a controlled environment to, regenerate collagen, et cetera, do some pretty cool stuff. And with that, he'll be heading to safety trials as well in the not so distant future. So super radical, interesting stuff. But to your question, it's, is there anything we can do? Like, is there anything in our sphere that could not take us back to pluripotent stem cells status, or even really shave, many decades off like Yamanaka's could, but walk that path? And Sebastiano showed in his lab that caloric restriction in an animal model actually really has this rejuvenating effect similar to Yamanaka. Sinclair and others have shown that there are chemical compounds that can behave Yamanaka-like, and they're called Yamanaka mimetics. There's a botanical actually called, you'd be familiar with, called forskolin, that in combination with others appears to have some of this Yamanaka mimetic or cellular rejuvenation effect. Alpha-ketoglutarate, an intermediate in our energy synthesis in our Krebs cycle in mitochondria, seems to have some of that as well. My area of interest and what I want to definitely, dive in and research next is the potential for polyphenols, the plant phytochemicals that were so influential in our research. Their Yamanaka mimetic effect. There is definitely preclinical research to suggest that those all important polyphenols, the reasons you're eating your fruits and veg, is certainly in part because they have some of this potential. That's what I think, and where I want our research to head.
Interesting. Yeah. So the research now, to an extent, shifting from, because you've established this idea that polyphenols, and I know your more recent work really focused in on those polyphenols, is a game changer insofar as it shaves off tears. And I wouldn't imagine this the exclusive or only mechanism, but potentially one of the mechanisms that enables that shaving is through these mimetics, which happen to be just all the colors in the herbs and the spices and the vegetable that we eat.
Yes. I mean, it's possible. There's a cool paper out, if anybody's familiar with the hallmarks of aging. There's a really cool paper out looking at those hallmarks. So these guys, the hallmarks are drivers of aging. So each one in and of itself can be associated with pushing aging forward. And, conversely, if you actually correct that hallmark, I think we have 13 of them now. You can reverse age.
Number does, yeah,
So
keeps growing.
there was a paper published recently looking at polyphenols influencing it and influencing all of the hallmarks. And so we can see they're very pleiotropic. They do a lot of different stuff. But I think that they're working their magic at the level of the epigenome. So the downstream hallmark effects, the anti-inflammatory, the guidance towards protein folding, the antioxidant potential, the anti-cancer potential. I mean, I think the pleiotropic benefit of polyphenols might be sourced right there. The root cause might be right there at the epigenome. So Yamanaka factors, that Yamanaka mimetic potential, or the potential of polyphenols to influence gene expression. I mean, it really doesn't get more root cause than that. And then downstream, we see antioxidant, anti-inflammatory, anti-cancer, and on and on.
Interesting. So whereas I'm almost positioning it as the antioxidant, et cetera, impact is the horse that is leading everything, you're almost proposing it's the epigenetic change and the other things just naturally fall into place.
Yeah, because you're manipulating what genes are on and what genes are off, and the proteins that are going to be produced, and the downstream, pathways that are going to be manipulated as a result. And we already know that you can rearrange the epigenome and create a stem cell. So we already know that the epigenome is housing the information about the aging phenomena, and that you can strip it and manipulate it and make something very, very young.
Yeah. And this is all just so beautifully driven through food.
And we can see, I mean, that's kind of the cool thing, in a really modest way. Well, I mean, compared to being a stem cell, it's a modest way, but so we can see that our dietary pattern rearranged right there, the epigenome, to something a little bit younger, in a very short period of time.
Yeah. I value the grounding and the data that you're able to bring to this conversation. And part of the reason I say this is, and I would imagine you've experienced this in clinical practice, right? I see a lot of people to support their understanding of their genes and how that will impact some of their health experiences, right? How their body shows up in the world. And so often my advice, some people feel, boils down to very similar things. This idea of sleeping, eating, and moving. And there's an element of people don't want to believe it because they want something a little bit sexier. And it's so powerful to hear how strong the very accessible things.
Yeah, that's right. And it's just, it's just going to get stronger. I think one of the exciting areas I'm interested in exploring, and it will be and is being explored, is just like kind of pinpoint prescription. So we know these polyphenols are important, but turning the volume up on a particular cocktail, and ultimately being able to individualize it for that human sitting in front of us. I mean, I am a functional medicine practitioner after all, so I want to individualize as much as possible. But if people here might be familiar with a compound called urolithin A, which is a made from, it's a postbiotic compound that comes from pomegranate, and some seeds, berries have the precursor polyphenols, and then it's transformed by a microbiome, and it makes urolithin A. And urolithin A is just a single polyphenol derived compound in a sea of hundreds of thousands that we have yet to identify. So we call them the dark matter of nutrition. We call all of this stuff because we haven't teased it out. And there's this one compound that has been very exquisitely researched. And it does have an age rejuvenation effect, immune rejuvenation effect, a mitorejuvenation effect. It can make more muscle in sedentary individuals. It can lower CRP. It can lower other inflammatory compounds. It can increase VO2 max in sedentary adults by almost a decade. Like, it's nuts. This is one little player from the
Yeah.
lowly pomegranate, from the
Yeah.
lowly, like, so if
Yeah.
you don't really appreciate how exquisitely powerful food is and know that where that one came from, there's another 100,000 we have yet to characterize and understand.
And
And
how it,
we will start
yeah.
to tease this out. So yeah, food is no joke.
And I think too what you're getting at, and I think this is a very powerful thing to get at, like you were talking about the erythrinae and pomegranates and how people like to reduce sometimes. I see this a lot with green tea. People are like, why would I drink green tea if I could just take a capsule that has EGCG, which is
Yeah,
the studied individual
yeah,
that's singular polyphenol that has been shown to have all the impact for breast cancer, et cetera, et cetera. And so
yeah.
people are like, why would I drink the thing if I could just take the pill?
Yes, yes.
And the answer is, well, sure, you could listen to a symphony with just a violin, or you could listen to the full symphony.
Right, that's right. That's
Right?
right. You know what? I have to say, I am a fan of pills. I am a fan of pills. I can't because
You're a
I'm so
naturopath, of course you are.
well, and I'm so bullish on polyphenols and
Yeah,
on certain polyphenols, and I'm not eating a massive curry every day. I'm just not doing it.
sure.
Um, so I will take it, and I will take a green tea extract. However, let me, appreciate what you've said. There is this incredible synergistic symphonic interaction between a well-designed fork full of food. So if you just think about a sophisticated stir fry or well-designed, robust salad, that information, that sophisticated information is reacting, with the brain, with your digestive juices, with your microbiome. It's being broken down and it's parsed out and it influences every step of the way and enters into circulation in this transformed way that ultimately will influence gene expression,
Yeah.
among a million other things. So to your point, food is absolutely, absolutely medicine. And for me and for other people, if I have to bang some of that out in a capsule form, I'm not going to kick myself out.
And I don't judge that either, because I guess the next question that I want to go to before we before we move into question answer, I do want to talk about this idea of lifespan. But before transitioning into that, there's a lot of study on, especially within North America, but globally at least, the quality of food or the lacking of nutrients, that there's
Yes.
a shift within our food, that
Yeah,
the vegetable, if you're eating a piece of kale today, it's very
it's
different from a
different.
piece of kale 50 years ago, let's say. Do you have any thoughts or concerns kind of on this depletion of nutrients? And in your mind, is that where more the supplements stand in that support and that gap?
That's a good point. So the cool thing about one of the cool things about our research was that we didn't require participants to buy organic,
Okay.
or regenerative or anything special.
Yeah.
It was, here's the dietary pattern. They were required to meet once a week with somebody from the nutrition team just to answer questions. That it wasn't like it was actually very controlled because we were under IRB. So there was a script the nutritionists
Mm.
had to follow. They couldn't influence the participant, but um, the participants were able to source their food however they saw fit. And this is incredibly important because it means that in theory, one could go to a very standard source and
Mm.
still see these differences. And that for me is incredibly important because not all of us have access to the pristine food
Yeah.
that we know is better. So
Yeah.
yeah, no question about it. It's absolutely, we can get better sourced food. I mean, regenerative agriculture is incredibly important. Clean sourced food is incredibly important. I mean, if you're
Yeah.
eating fish and you're not really paying attention to it, you probably at this point have a mercury burden, unfortunately. Like our food system, our food supply is pretty polluted. Um, and despite that, we were able to see these favorable changes in our study
Yeah.
participants, eating, standard sourced food.
I thank you for that. Because I think sometimes, especially within our biohacking circle, there is a fear of, if you're not doing it perfect, you're sacrifice. Like, I'll say, if people trying to serve the perfect, then sacrifice the good, and then don't get anywhere. So I'm glad.
Yeah, yeah, I know. I'm always happy when this question comes up and I can say this is what we
Yeah,
were able to show, because
I
it's
love that.
because many, 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 many humans don't have access
Yeah,
to really high quality. So it's a lesser quality of kale, but it's still a freaking piece of kale. It's a piece of kale.
yeah, it's not a potato chip.
Right.
Yeah.
That's right.
So before we transition to questions and answers and audience again, I would really encourage if you have any questions or answers, well, answers, if you have any answers, please share them. But if you have any questions, toss them in the Q&A box. But before we jumped on, we were talking about something very fascinating, or at least you were teaching me or speaking about this concept of lifespan. And so I wonder if you can dive into this idea of lifespan a little bit, and this because I think it's really fascinating to me. I think when I first got into the idea, the science and the medicine around aging,
Mhm.
when I had to sit down and someone asked me the question of, well, what exactly is aging? How would you define
Yeah.
it?
Yeah.
And
Yeah.
then I chased my tail a little bit,
Like,
right? I was like, getting older, like based on time. And that's a valid answer. But then, you just referenced a paper that I think to your point, we're up to what, 12 or 13 elements of aging. I don't keep up with
Yeah,
the
well,
number.
Hallmark, yeah, the hallmarks, yeah, that are
Yeah.
associated with making, either, yeah, manipulating the aging process. In some form, they're associated with it. Yeah.
Mhm, mhm. Yeah. So my question is, there's a lot of research, yours included, that says we can really shift how our body is experiencing and aging within the world. But there's still this question of how far can we push this envelope? Are we ever going to get to a point where we are living, beyond the expected 100, 120 years, whatever that happy little cap that currently has been put there? Can you talk
Um,
a little bit about that?
yeah, yeah, I sure can. There's first of all, I think that actually, I'll back up a second and say, of course, saying what aging is would stump you, because scientists are debating on what aging is, and what the aging phenomena is really has yet to be agreed upon and characterized. Like, it's still nebulous.
Mhm.
Probably less so than the dark matter of nutrition. Nutrition is still out, will out
Okay,
complex
yeah. Yeah.
it.
I
But
really I love this though. I love that science hasn't really agreed on exactly what is
yeah,
aging. And
yeah, and
to
you'll
lay people,
find,
that's like,
yeah, one of the people that I talked to on our master class, Matt Caberland, is a really highly regarded biogerontologist, and kind of one of the individuals at the center of being like, yeah, what the heck is aging anyway? I think that we are making inroads into define it though. So I differ on him in some fundamental ways, and I think he tends to be a little bit more literal around interpretation. But so I think that there are two tracks. So we know if I'm smoking, I'm accelerating my biological age. So there's these environmental exposures,
mhm,
and
sure.
we can do a lot of our heavy lifting there. And Matt would agree, and you would agree. I mean, in fact, Matt said on our interview that we could very rapidly extend life expectancy by 15 years, if we're just able to get in and just turn the volume down on some of the chronic diseases of aging. Like, if we just get in and do some of these these basic lifestyle interventions, we can change things fast. And we should see that in the age of wearables, access to continuous glucose monitors, the availability of certain nutrients, et cetera, just people having more awareness of how their choices are influencing their health. We should be able to get in there and manipulate lifespan in the case of turning the volume down on chronic disease. But then the other thing you're asking about is, can we actually push out maximum lifespan? Some people talk about escape velocity, which is immortality. That's, if you reverse bioage by a year every year, you've effectively stopped aging, right? If you
Yeah.
stop aging for every year by a year.
Yeah.
And what I will say as a
But
sidebar, we've had people doing our dietary pattern long term, and we
mm,
don't see them getting younger and younger and younger, but we
okay.
do see
Okay.
them aging at a slower rate, which is kind of
Okay.
cool. We do
Yeah.
see them, and we can see people maintain some of
Yeah.
those reductions, which is pretty cool. It's just a small cohort and it's anecdotal, but it's still cool. I think that, so there's this environmental aging phenomena that we can get in there and manipulate. And then there's probably a programmed aging, and there's a clock out that you and I, there's actually multiple measures out looking at similar proteins that can now track aging across mammals. So across mammals, we share certain elements of the aging phenomena. And this suggests that aging is within mammalians species, that it's a shared experience. And just as a side note, they're using these clocks to measure the age of certain mammals that we really don't have access to. And they can see accelerated aging in certain mammals that are, kind of under duress, like polar bears, where they're losing some of their terrain with the change of climate. They can see that their aging is accelerated, and certain, mammals that are, they can't keep in captivity, etc. Like they're really able to kind of do some cool exploration work with this new suite of clocks. But these, because they're able to look at maximum life expectancy across mammals using these tools as well. Right now, so what the scientists working on this say is that, aging appears to be what they call it a pseudo-programmed event. They also say that thus far the tools that are available for them to test doesn't touch maximum life expectancy. That doesn't mean it won't in the future, but that's what they're arguing around right now. I mean, but for me personally, I mean, if you can give me 100 good years, like I came to motherhood late in the game, and there's no question I want to be with my kiddo, and her kids, my grandbabies and my great grandbabies, as healthy and strong and robust as I can. I don't have any attachment to escape velocity. I think that sounds pretty darn weird, quite frankly. But if we can just hit maximum life expectancy more consistently, than the odd human. Yeah, I mean, that to me would be absolutely extraordinary. And that would be an all hands on deck operation. Like we'll really need to be using all the tools we have, including, diet and lifestyle choices.
Yeah. Okay. All right. Well, thank you. I'm very happy with that. I want to extend my happiness to the audience because I've been watching the questions come in for you, Dr. Fitzgerald. So our first question is coming from Lynn. And Lynn is asking if you have thoughts on injectable peptides in terms of longevity and health.
Yeah. Well, peptides, they're just by definition a short, string of amino acids. It's a little protein. So they're far and wide in what they do. They're not kind of uniform in their mechanism. I think peptides are kind of cool therapy. Some of them, like, there are some peptides that people are using to attempt to kind of turn the volume up a little bit on growth hormone, maintain muscle mass, and some of the benefits that come with that without some of the potential risks of using actual growth hormone. I think I think peptides could have a cool place in the longevity arsenal. BPC 157 we use in clinical practice now with some regularity, for gut health, joint health, etc. I want to say that there's not a ton of human data on it. This is an area of exploration. So Lynn, if you're like, I really want to try peptides, go for it. It could be a fun exploration under, with a provider who's trained in them and can help you on that journey. I will say that I have a lot. So since our research came out, a lot of my patient base now are biohackers, probably not dissimilar to yourselves, and people will come to me on a pretty sexy cocktail of interventions that hasn't been appropriately selected for them. It's been more designed based on, their who's got the loudest voice at the time. And And if your underlying issues aren't corrected, um, your flavor of inflammation or inflammation, your optimal dietary. So the younger your dietary pattern can be modified. It still has all the components and the ratios that we want, but it's modified for you. Like if your individualized, structure hasn't been defined yet, you're missing that core essential longevity piece. And then once that's there, you can start to layer on some of the sexy stuff.
Yeah. Okay. I like that. I like that in particular, the idea of working with someone who knows you and can guide that well, as
Yes.
opposed to you and I both see laundry lists of like, I saw this person on
Yeah.
Instagram and then I visited this doctor once and here are the
Yeah.
30 things I'm now on. Yeah.
Right. Or, this is really popular right now. There was a study on this, so I'm taking it. There was a
Yeah.
study on this. But
Yeah.
does your body actually need it? Is it going to benefit from it
Yeah.
in the way that it did in that study, or for some of the study population?
Yeah.
It's really worth figuring that out, because
Mhm.
your biohacking bang for your buck will grow exponentially if it's really
Yeah.
shaped to
Yeah.
you, the individual.
Yeah. Yeah. I love that. Okay. Our next question is coming from Marianne. So Marianne was saying that, and Marianne's someone who has the DNA 360. We look at a gene called BDR, and that's the vitamin D receptor. And unfortunately, with a suboptimal presentation there, it's tied to several unfortunate outcomes like osteoporosis, a little bit of immune disability, because that receptor isn't receiving the vitamin D and receiving it as strongly as it could be. And
Hmm.
so right now, one of the best remediations, for better or worse, is simply ensuring you have adequate vitamin D within blood work, because we want to know that that's never low. And so the vitamin D that is connecting with your receptor is always, those receptors are always able to have vitamin D. So her question really sits around, what is an ideal level? And in her instance, they're really saying, like, I have a few autoimmune conditions. Do you within your practice have, and this is for a general patient, right? We don't know any of Marianne's history, but do we have a general, preference when it comes to longevity, when it comes to someone who wants to live well and possibly in their history they have an autoimmune condition? Do you have a preferred range when it comes to vitamin D?
I mean, I like to see it in the 50s,
Okay.
and I would probably be okay with mid 40s up
Yeah.
to maybe 70. 70 might be
Yeah.
pushing it a little bit. There was a time when we were going very high with vitamin
Yeah.
D, and there was a time when
Yeah.
we were way, way, way too low.
Yeah.
I think we're realizing that the sweet spot is a little bit more modest. That's
Yeah. Yeah.
the safe area and the safe range. I mean, for somebody who's got a VDR variant that's going to compromise, their ability to utilize it, it may be that serum levels need to be higher. But that I would
Yeah.
defer to your experience on.
Yeah, no, I like your ranges. My preference, at least for people who are suboptimal in that space, is policing their vitamin D a little bit more, doing more frequent measurements and ensuring they're always within that happy
Good.
range, as opposed to hyperdosing or megadosing. Yeah, yeah. All right. Our next question is coming from Marianne, and they're asking, in your research or experience, do you know if bereavement, so grief, has an impact on aging? And if so, in particular, as you go through that cycling, what can be done to reverse some of that impact?
That's a great question. That's a really good question. Actually, we were talking a little bit about offline. Actually, we were talking about the intergenerational potential
Mm,
of epigenetic inheritance, which
mm,
um, there's a decent body of science on. Yeah, there's no doubt our what our psychological experience will influence epigenetics. We know trauma will is pro aging. Bereavement, may fall into the trauma continuum. It would depend on what your experience is. I would say that likely it does influence epigenetic expression. We know that so acute stress events are pro aging, even pregnancy. But then you have baby, and especially if you're breastfeeding, you can, all of that turns back. It resolves. It levels out. So that pro-aging experience is reversed. Which, by the way, Matt Kaberlin would argue means that you weren't really looking at aging, because once the stress event goes, it reverses. But for me, I mean, I don't. That feels a little bit like semantic. I think in that experience, those pressures did have something that physiologically reflects a pro-aging experience. So yeah, I would say that bereavement probably does, or probably can. I want to say, interestingly, to that, the PTSD in Vietnam veterans was shown to change DNA methylation patterns um, negatively. Not, I don't, possibly pro-aging, but there was possibly overlap with pro-aging, but there was the focus of the research was on influencing, neurotransmitter production, feel-good hormones, oxytocin, et cetera, et cetera. So you could see this in PTSD individuals. And in this cohort, PTSD in Vietnam veterans, therapy changed those methylation patterns. So those those genes that we wanted on
Yeah.
the therapeutic experience in these PTSD patients was actually, it reversed those negative changes. It's really cool. You can see changes across generations, like World Trade Center, women who were pregnant then, you can see that offspring have higher rates of allergy, asthma, autism.
Yeah.
There was the Project Ice Storm was in Quebec, in your neck of the woods.
It's been.
And they studied epigenetic changes. So women who were pregnant during that, it was just a 2-week event, but it was intense. Women who were pregnant gave birth to offspring who there were, again, higher rates of autism. And I think allergies as well, interestingly enough. I think.
Oh, wow. Yeah.
Yeah, but it changed epigenetics, it changed gene expression. Holocaust survivors and generational influence on Holocaust survivors. You can see a bias towards some of the diseases of aging, heart disease. You can actually see towards depression and so forth. One area, though, that's been criticized, and I talk about this actually in my book, is that we haven't studied the patterns of resilience. So there's been a lot of attention towards trauma. You can see in regions in areas where starvation is experienced, like, seasonally, so there's super dry season, you can see epigenetic changes that are passed on to generations. But the genes of resilience, and I think that would be very interesting to look at. And Holocaust, there were survivors in the Holocaust that could potentially, who thrived, who actually thrived, and looking at their, subsequent generation gene expression could be interesting. So understanding and cultivating resilience patterns is something that I think is incredibly important. There was actually at a McGill University a mentor and actually an author on our first paper, Moshe Saf, who has looked at PTSD in an animal model, and vitamin A and acetylmethionine changed the PT. So it was a PTSD animal model, and they were able to use those nutrients and turn it around and change gene expression. They were able to see that gene expression difference in the brain tissue.
So vitamin A and a brain-specific methyl donor was able.
And acetylmethionine.
Yeah. Wow. Yeah. Okay. Okay.
Yeah.
I like that response, because I think, humans have that negative bias, right? We study disease, not health. We study.
And that's been written about. Yeah. Like what, we focus on the trauma component without, we really need to understand what resiliency looks like. Moshe Saf, who I've actually podcasted with, and he's so ridiculously interesting. His focus has been on, diagnosing these epigenetic changes in utero and just correcting them through, simple supplement and perhaps dietary changes to mom, and just changing that gene expression in utero. So you don't, you turn off the potential for the trauma. You turn off the potential for, increased risk of immune changes, etc.
Yeah. Okay.
There are studies in African Americans, and Native Americans as well, Kat. I do talk about that in my book. Yeah, definitely you can see like adopting the dietary pattern in the US, in cultures that evolved with a different dietary pattern is just terrible. But I mean that's one example that comes off the top of my head. But yes, you can there it has been looked at, that generational trauma.
Yeah, right. I have another next question for you here is coming.
Actually, let me just say something on that, because we're talking about some of these challenging trauma components. So we know that diet and lifestyle, that's what we've been talking about, can favorably change gene expression. We know eating these polyphenols, engaging in exercise, the methyl donor-rich foods, so we have information now, even as the resilience presentation needs to be better characterized and understood. We already have tools that have been identified to change gene expression patterns towards something more favorable at our disposal. So to me, the argument, the intervention is clear, even as we need more data.
Yeah. I like that. The power of change, or the possibility of change.
Yeah, for sure.
Yeah, which is important, because sometimes, especially in those circumstances, that doesn't seem feasible. Yeah.
I think, and the other thing, I'm sorry, I'm going to say one more thing on it.
Please.
For just, it's an area that I just haven't talked about. I was talking about a lot. I mean, I was talking about it all the time during the book, but my thinking has just evolved, and now I'm sort of myopically focused on certain polyphenols. But we can understand, like, you can know from your own history and your generational history whether you might have some of that trauma housed in your epigenome. I talk about in my book that, half my family comes from Poland, and we all migrated, and we know that we migrated at least in part due to food scarcity. So like a thrifty epigenome phenotype is in my family. If we aren't careful about what we're eating, diabetes is right there for us, or blood sugar issues is very close. We know also that the stress experience can happen faster. So thinking about, my patients that I've treated and just coming through this lens, and you may know this about yourself, somebody listening, that, there was this stress process in my family, whatever it looks like, be it something like my family, where we moved to the US at a time of discontent, or if there was abuse in the home. We know adverse childhood events have this effect. We know lack of touch in infants will have this lasting epigenetic imprint, and it can change with the addition of touch. But I guess my point is that if we think that this is in our story, if this resonates, then you give yourself the room to know, I will respond to this. My stress threshold is lower. That will prompt anxiety in me faster. Like, these are some of the tools that we can bring forward, and that I try to bring forward to my patients. Yes.
I think one of the most powerful things that I've seen in some of the DNA consults that I do is speaking to exactly that, either a stress or a metabolic, or whatever threshold, and then the person has something a little more tangible to grab onto. They're able to say, I'm not the villain. This is how my genes are set up. It's not my fault. This is my genes, and now that I know that, I can act a little bit differently. And so to your point, if the family has incurred this trauma, your childhood perhaps incurred this trauma, with that awareness, you can shift how you're acting towards yourself.
Yeah. I think that's right. Just, a little grace.
Yeah. Goes hard to afford sometimes for yourself, but goes such a long way. Yeah. All right. Are you ready for the next question? I'm happy if you have another tangent. I'm very happy for that. All right. let's see. Syl is asking the question, have you seen the diet in Younger You? So that book that we just mentioned, halt progression in patients with cancer. So specifically those that already have METs, metastatic or
Um,
metastatic cancer.
So I would say that I've definitely used the Young dietary pattern, in fact, in patients with cancer.
Mhm,
And there's a case study in the book
mhm,
in an individual who used a dietary pattern. She's actually a nutritionist in my practice, and she's still a nutritionist in my practice. And we use this all the time. But she walks through her own history with breast cancer
mhm,
and using the dietary pattern.
mhm,
So as I said at the opener, cancer hijacks epigenetics. There's so much research on it. I mean, all the chronic diseases of aging will hijack epigenetics, but there are such strong data with regard to cancer, such strong data. In fact, some of the emerging technology for diagnosing cancer very, very early looks
mhm,
at DNA methylation
mhm.
patterns. That's what
Yeah,
it's doing.
yeah.
Um, we know, and there's a table in the book. Look, I call them nutrient responsive genes, where it, and it's mostly cell study. There was just not that much animal data, but more animal and human data are coming out showing the power of, generally speaking, polyphenols on
Mm,
re-expressing protective tumor suppressor genes that are hypermethylated.
yeah.
So if somebody who is listening has cancer, you know that your epigenetics in that tumor microenvironment are hijacked by the cancer itself, and using these interventions in your dietary pattern to help re-express is absolutely makes sense. Absolutely makes sense. And I can say pretty cool is that more research is coming out on these in humans. There was a study that just came out looking at proanthocyanidins, like in grapeseed and so forth, in a particular package to make it very bioavailable to
Mm,
make it to get it into the tumor microenvironment, shutting down cancer stem cells.
mm,
Yeah, so just stay tuned. It's
mm,
going to be dietary pattern, what we're eating in our food, well designed fork, all the way to probably drug delivered, nanoparticle
mm,
um,
mm.
polyphenols just getting in there and shutting
Yeah,
down cancer. So it just makes absolute sense to use this dietary pattern is
yeah,
anti-cancer. It's good in autoimmune, like really any chronic disease. It
yeah.
would be appropriate.
I love the magic that comes out of nature. Like to hear that something from the rapeseed can do that. I've heard several trees, certain mushrooms, when in delivery, can be so supportive.
Yes, that's right.
Yeah, yeah, yeah. All right. I hope that answered your question. The next one I have is from Nathaniel, and they're wondering if you can explore. So you've definitely talked in terms of uh, aging clocks, biological aging clocks that kind of speak to the rate of aging. Are there other clocks that are developed that are a little bit more organ specific? So, for
Yes.
example, saying like, hey, your heart, your cardiovascular system showing a bit more wear and
Yep.
tear than perhaps your brain.
Yep.
Yeah.
Yes, for sure. Yeah, there are. Um, yeah, in fact, I think in a way, that's where the science is going. So we used a multi-tissue clock, one that's a bit, reflective of overall
Hmm.
rate of
Hmm.
aging, although probably it's more reflective of certain cell types and organs. But yes, there
Hmm.
are clocks looking at the rate of aging of specific organs that are available. I think that science is still emerging. I'll be totally honest, but it's out there. I mean, but there's other tools we can use. You don't necessarily need to lean on epigenetics, like you could
Hmm.
do a pulmonary function test, a VO2
Hmm.
max.
Yeah.
Um, when I live in Mexico now, but right just before I moved here a couple of years ago, I went to the local or Yukon. I live in Connecticut, so I went to the University of Connecticut at Stores, where they have um, exercise research center, and they'll do your VO2. They'll measure your
Mhm.
VO2, and that's an awesome way. And then there are charts out there, and you can see if the age range that your number
Mhm.
correlates with.
Yeah.
Um, there are proteomics clocks, um, glycomic clocks. There's a bunch of different tools.
Yeah.
I think I'm bullish on epigenetics. But yeah, I mean, you can look at even some of the standard chemistries.
Yeah.
Um,
Yeah.
you can look at those and infer something about the rate of aging,
Yeah. Yeah.
like a CRP or,
Yeah. Yeah. And
we,
audience, if you're interested in doing such a test, we'll link it in the chat, but we do have one called the DNA Aging through the DNA company, if that's something you're hoping to get your age clock there. Yeah. All right.
let me tell you,
Mhm.
interestingly, in our book, we have, and we can give you a link to this. We have a questionnaire. Believe,
Mm.
yeah, we created a questionnaire. We wanted to have something that was free for anyone who wanted it. And we do have a cohort of over 70 individuals that did the questionnaire plus a clock. And we're able
Mm.
to see that the questionnaire actually does correlate with the clock, which was kind of exciting.
Amazing.
Yeah, it could be something
I
that we'll
like that.
publish on at some point in time.
Yeah.
But that's
Yeah.
free, and that's kicking around our website.
Okay, perfect. I think your website's in the chat, and we'll make sure we put that back in the chat so people don't have to scroll to find it. Yeah. All right. The next question I have is coming from Marianne, and this throws back a little bit to pomegranates. They're asking, on a daily basis or on a weekly basis, whatever that might look like, how much pomegranates? Is it a sprinkling, or are we talking bushels and barrels?
Oh yeah, that's a really good question, right? You want to know something super funny? In my office in Connecticut, I still have my brick and mortar office in Connecticut, even though we're here in Mexico. And one of the doctors there, Dr. Ken Lewin,
Yeah.
I'll throw him under the bus. He would eat just the white part, because if you really like, well, maybe not
Oh
just, but he ate
wow.
less of
So
the
the
red.
rind.
Yeah, yeah. I mean, because that's incredibly nutritious. You just can't throw it out. And the red part has so much sugar in it. That's the
Wow.
challenge. That's really the challenge with pomegranate.
Mm.
We
This is getting at
all,
like the orange and the rind. There's so much nutrition in the rind of
yeah.
the orange. Yeah.
My mom used to always make us eat the white part, and I was just like, and my kid is equally, my daughter Isabella is super annoyed by the white part. I'm like, you gotta eat the white part. Like I sound just like my mom. Um, So that's what he would do. But to your point, it's two things about getting to this amazing urolithin A that has all this data on it. A, you
Mm,
need the microbiome that can take
mm,
the ellagic acid and the lagitannins from pomegranate, etc., berries and so forth, and then transform it and make the urolithin A. And not all of us do that. And it's quite possibly you would require a lot. So there is a place for using this supplement. There is a place for using that urolithin A that that they're able to produce. But there's another dietary pattern that was published on called the Direct Plus.
mm,
Um, and they showed dietary urolithins because they were on this dietary pattern, and then they measured the urolithins in the urine to get an idea, or the surrogate marker. So they were able to see that from this dietary pattern, they did increase these urolithins, and they appeared to be associated with some of the really cool epigenetic changes that they made.
mhm,
So I would say that you just, again, want to be making sure that you're consuming some of them. But I would not expect to get to those super
mhm.
high doses that they're
Yeah,
researching in that
yeah,
urolithin A product that reversed
yeah.
um,
Okay.
VO2 max age and all of that.
Okay. 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 So it's going to the symphony, but then also appreciating every once in a while you got to take a violin, just the
Yeah,
single.
that's right.
Yeah.
Yeah, in that yeah, but it's cool that there are data out there showing
Yeah.
that the symphony works, that you
Yeah.
don't have to just go through for the concentrated supplement.
Yeah. Yeah. I like that. I like that. And I like that you also brought in, because I think our last question is coming from Nina, and they're asking, what the microbiome influence is in terms of polyphenols, right? Because we ingest all these foods and then it hits our tummy, it hits the digestion, it hits our biome. And
Yeah.
is that an amplifying effect? And what I'm hearing from you, really different biomes will accentuate or bring out different elements within foods based on what the bacteria
They'll
that's.
transform them. They'll
Mhm.
take compound A, like ellagic acid. In the case of urolithin A, they'll take that ellagic acid from your pomegranates or your berries or your nuts
Mhm.
and transform it into, actually, there's a few different urolithins. It seems like the heavy lifter is urolithin A, but there's B and I believe a C that are also good. So depending on your collection of microbes, you'll
Mhm.
make it or not. You'll make
Mhm.
a lot or you'll make a little. Um, I think that we've all damaged our guts pretty significantly.
Mhm.
Um,
Yeah.
the chief science officer at the company that makes urolithin A doesn't. He does not. He's not able to make. He doesn't have the microbiome to be able
Mhm.
to take the pomegranates and transform it into.
Mhm.
I've tested myself and I'm able to, which is kind of cool.
Really?
Um,
Yeah.
uh, so I think the moral of the story here is that we need to be nurturing our microbiome always. When we're eating this robust dietary pattern that I'm talking about
Yeah.
in our research, like you're eating this whole foods dietary pattern, it is by design nurturing your microbiome. We didn't include fermented food in our study
Mhm. Okay.
intervention, but I do recommend it in my book. There's a place for just doing some fermented foods. We had people take a probiotic in our study. You can do that, but we need to just remember that our microbiome transforms what we're eating, and it does so to the benefit of our systemic,
Mhm.
health.
Mhm.
Um, Not all polyphenols that we eat in our food are sort of radically transformed. Like I don't know that we understand it.
Okay.
Curcumin, it looks like it exerts some of its magic just being directly
Yeah.
absorbed
Yeah.
as curcumin. So
Yeah.
so this is an area of much needed exploration. It falls into that dark matter of nutrition camp. So some we just want directly bioavailable, others we need to be transformed.
Yeah. Yeah. I love the idea that so much of turmeric or curcumin, but more so turmeric, its impact is within the biome and effectively not even being absorbed. It's more dense.
Right, that's
Yeah.
interesting. Yeah. Yeah.
Yeah. Yeah. Yeah. It is so, I think one thing I always try to remind our audience is when we talk, because sometimes we can get in the habit of within these conversations of focusing on all the ways that our health can go wrong, because there's so many opportunities within the modern world, but it's refreshing to hear all the ways that things can go right, that there's
Yeah.
so many different ways that can contribute
Yeah.
to good health.
Well, and one of the cool things that I actually talked about in the book
Yeah.
is that when this diet is in and of itself just really detoxifying. There's um there's this scientist at the University of Kentucky. His name is Bernard Hennig, and I've been following him for a million years. I've tried to get him on the podcast, and I haven't. I don't think he's ever responded to me.
One
Um,
day, one day.
yeah, I don't. He may already be retired. He's been there for a long time. But
Okay.
his area of investigation has been on looking at food offsetting the negative influence of toxins. So, for example,
Mm,
if
mm,
you're consuming fish, if you're getting EPA and DHA in the diet, you can actually shut down the pro-inflammatory effect of PCBs. So they're driving. So
mm,
PCBs drive this pro-inflammatory eicosanoid cascade, and
yeah.
we can inhibit that, by
Mhm.
just making sure we're consuming adequate EPA and DHA. But also, we can inhibit, or excuse me, we can consume some of the botanicals, like going back to turmeric, that can have a similar inhibitory effect there. So
Yeah.
so our diet,
Yeah.
and additionally, not so it's shutting down the mechanism of action of these toxins in the
Mm,
body.
yeah.
On one hand, the dietary pattern can help us clear the toxins, get them out of the body, but we all have a burden. And so the mechanism of action by which they do their damage, we can
Mhm.
influence favorably with that same dietary pattern.
Yeah. Yeah. I love I love that. I love that because so often people get defeated before they even start. And so to hear that there is balance in doing the good. Yeah. Yeah,
Yeah, we can offset the
Yeah.
influence, the inevitable
Yeah.
toxic burden that we all have. We can
Yeah.
offset its damage. We have
Yeah.
that power. And that's his focus of research, actually looking at, the nutrients that shut
Just
that down.
so powerful to think through, because I find anyone within the space of environmental medicine, there's this mentality of you're not going to be able to control everything, so just accept that's going to be there. But I like this balance point of, but the things you're doing might actually negate that.
Yes.
Yeah. 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 I am Dr. Fitzgerald. Thank you so very much for being here with us this evening and offering this idea that younger you is not entirely inaccessible, right? And something that through basics as well as some fancy things, right? The symphony and the violin, you can really shift your age, your biologic age, which is something so powerful. And that's at any age. Audience, remember, her research was done at those in middle age. We're not talking about 20-year-olds, right? We're talking about those midlife. So, Dr. Fitzgerald, thank you so very much. This has been an absolute delight, personally, as well as I would imagine the audience as well. So thank you so very much.
Thanks, everybody.
Yeah. Au revoir, mes amis. We'll see you next week. Bye, guys.